Students, now we will discuss heat and thermodynamics. Next topic is relation between Cp and Cv of an ideal gas, or it is called Maier's relation. Consider 1 mole of ideal gas enclosed in a cylinder fitted with weightless and frictionless piston. This is a cylinder fitted with a weightless and frictionless piston, and volume of the gas is capital V. Let A be the area of cross section of the piston and P be the external pressure acting on it. See in the diagram, external pressure is capital P. Let the gas be heated through a small temperature delta T at constant volume. The amount of heat required is given by Q1 is equal to C1 into delta T, because number of mole of gas is equal to 1. Let it be equation number 1, where Cv is specific heat at constant volume. And from first law of thermodynamics, we get Q1 is equal to delta U plus 0, because at constant volume W is equal to 0. Therefore Q1 is equal to delta U. Let it be equation number 2. From equation 1 and equation 2, we get delta U is equal to Cv into delta T. Let it be equation number 3. Now heat the gas through same temperature delta T at constant pressure. The amount of heat required is given by Q2 is equal to Cp into delta T. Let it be equation number 4, where Cp is specific heat at constant pressure. And from first law of thermodynamics, we get Q2 is equal to delta U plus W. Let it be equation number 5, where delta U is the increase in internal energy is same as the increase in temperature is same, and the amount of work done is given by, see in the diagram, the expansion is piston moves through small distance delta x. W is equal to F into delta x, where delta x is the small distance through which piston is pushed out, and F is the force acting on the piston, given by F is equal to P into A, pressure into area, where A is the area of the piston. Therefore W is equal to P into A delta x, or W is equal to P into delta V, where delta V is the increase in volume of the gas. Therefore from equation 3, equation 4 and equation 5, we get Cp into delta T is equal to Cv into delta T plus P into delta V. Let it be equation number 6. According to gas equation, for 1 mole of gas, PV is equal to RT. R is gas constant. At constant pressure, we get P into delta V is equal to R into delta T, as R is constant and P is also constant. Putting this value in equation number 6, so we get Cp into delta T is equal to Cv into delta T plus R into delta T. Now in the right hand side, delta T is common. So take it common. We get Cp into delta T is equal to Cv plus capital R within the bracket into delta T. Delta T cancel each other. So we get Cp is equal to Cv plus capital R, or Cp minus Cv is equal to capital R, or in calories Cp minus Cv is equal to R upon capital J. Let it be equation number 7, where capital J is Joule's constant used to convert units from joule to calorie. So Cp minus Cv is equal to R upon J is the relation between Cp and Cv, or it is called Mayer's relation. So thank you very much.